All right, we're going to get started here. Thanks a lot, everyone, for attending. In this session, okay, let me zoom over to the title here. Today, we're going to talk about, from the management view, how would the cloud security services help your organization to leapfrog on security? And my name is Jason Lam. I have been a SANS instructor for many years. I think the official count is like 15 or 17. I've been around for a long time. And looking at the curriculum here, which I was involved in the SEC 522. And recently, I also wrote a short course called the Management 520, which is Leading Cloud Security Design and Implementation, which really align with our topic today. And my personal background here is that I have been in the industry for about 20 years. I started out as a developer, working for an ISP, and they got hacked. That's how I got involved in security. My day job nowadays is I work for a really large financial organization in a leadership role. I was based in Asia in a few years ago, was doing a CISO role, Chief Information Security Officer role there, and then moved back over to the US here. And now here I am, leading up certain security components. And when I'm not doing my day job, I tell people that I'm a superhero. I write courses and I help people understand security so that they can protect their own organizations. That's really my background here, and obviously very involved in the cloud security area nowadays. So let's get into some of our material here. The first thing that we want to talk about is, hey, what do we want to talk about today? It's all about how do you leapfrog in security. And to talk about leapfrogging in security, what we want to understand is, hey, where do you stop, right? Before you even get going, where do you start? So cloud capabilities obviously offer a lot of opportunities for organizations nowadays. From the agility, scalability, there are a lot of people talking about, hey, how do I make things quicker, right? And cloud definitely offers a lot of capabilities there. You don't really need to reserve to say, hey, I need these 5 servers. Hey, the capabilities is there, right? You just need to go and configure or turn things on. And then I don't need to tell you that the cost optimization, hey, you only pay for what you consume. And also it prospered the innovation within organizations and let organizations focus on what matters. Hey, most organizations are not there to manage their hardware, manage their infrastructure, and so on. What they want to do is really transform some business logic into a service that serves their customer, right? That's what matters. And then, I would call that there are some analogy about power, right? Like electricity about 100 years ago, there were big companies back then that have people managing, their power. Nowadays, how many companies actually employ people to just manage their power? Power comes, right? And it works. So that's sort of the analogy here, right? Like cloud offers us the capability. Okay, so we don't have to worry about the hardware of the IT infrastructure. And last thing here, there is a finger, pointing at this particular bullet. We're able to leverage the world-class capabilities that the cloud service provider offer to us. What does that mean? Well, particularly on the security side, those are the focal point today that we're going to talk about, right? There are tons and tons of security capabilities that the cloud service providers have made available for us to consume. And people can just easily configure and say, yep, hey, I want that particular service. And you're it, right? Like you can consume it very quickly. Now, and then on the right-hand side of the page, that's bringing us back into the reality. Before we even leapfrog, hey, you need to be able to consume the cloud. You need to be in the cloud to be able to leverage some of these capabilities. So there are disciplined approaches to move workload to the cloud. Well, as I talk about, I wrote a course to talk about some of these transformation. I'm not going to talk too much about it, but it requires certain level of careful planning, configuration and permission, identity. Those are some of the big struggles that a lot of organizations need to contend with. But once you get going, then the question becomes, hey, I'm on this journey now. What could I benefit out of it, right? So that's really get us to our conversation today. And most of your cloud journey in a lot of organizations, hey, unless you're a brand new company, you have no technical debt, right? You're going to start off with certain level of like on-premise, security posture, on-premise setup, and so on. A lot of the cloud journey for a lot of organizations start off there, right? All you're trying to do is to match up the cloud environment to your existing security posture. Because, hey, you may have promised, or committed to your regulator, your board, your clients to say, hey, here is my security level. And you're trying to get the cloud environment to match up to it, right? So that's not surprising. And a lot of the organizations start off with that, right? There is like, that's your starting point. But hey, don't let that hold you back. The whole point about it is that, once you start there, it gives you the ability to start exploring the capabilities within the CSP, cloud service provider, like namely the AWS, the Google GCP, or the Microsoft Azure. You can actually start exploring and expedite on areas that would benefit you the most. The good thing about cloud is agility, meaning the cloud service provider have all these capabilities all ready to go. You just need to turn it on, right? You just need to configure it. And then, so why are we talking about all these capabilities? Is great because, hey, those cloud service provider, the AWS and so on, they spend so much resources into the security research. Is economy of scale, right? Hey, you, me, everybody else, consume the service from cloud, and we consolidate our resources and we pay them. They then go and research on these cloud security services and make it really good. And it's relatively low cost. And why would I say that? Well, over time, it may not be that low of a cost, but at least at the starting point, the initial cost is very low. For example, later on, we'll talk about security monitoring. It used to be that organizations would need to buy no less than hundreds of thousands of licensing and so on before you can even start monitoring, right? Nowadays, the cloud provider make it really simple, right? Hey, if you promise to pay it monthly, yeah, maybe when you start off, consuming very little of the service, you're not even paying maybe $10 and so on. So the entrance fee is really low. And today, we're particularly going to focus on some of the areas to leapfrog. Hey, there are a lot of different areas. I'm going to use 3 different areas as examples to talk a little bit about what organizations can look forward to. Once you start your cloud journey, you can easily adopt some of these services and make your security posture a lot better, right? This is much better than your on-prem data hosting. You can actually leapfrog very quickly. So those 3 areas are security monitoring and response, the crypto, the encryption, and then the third one is really a combo, is the DDoS mitigation and DNS services. So those are the key topics that we're going to explore today. Now, The first area that we're going to look into is security monitoring. Okay. So what are the capabilities there? Like, first of all, let's talk about what security monitoring really means. Whether you are doing it on-prem, on-premise, like old traditional model, whether you're doing it in the cloud, you still have all these components. The ecosystem looks like this. First of all, there's the log management component. What that means is, hey, in order to say you're doing security monitoring, you have to have something to monitor. And the log management means you're going to collect all the log files, all the log entries, the events that are happening within your network. You're going to go and collect it and store it. Okay. And you may have certain level of analytics and so on. Those analytics means that, at least you know how much data you're collecting. You will eventually have to go and store it and archive it at some point, because, hey, logs that are only available for a day, that's not good enough. Usually, most organizations start off with 3 to 6 months, right? And certain organizations for certain logs goes, 7, 10 years, or the eternity. They never delete their logs. So that would be component number one, the log management component. And then we also have the monitoring and analysis. So all those data that you have collected, you would have to have the smarts to actually, the logic to actually analyze it and understand what's going on. That's where your indicator of compromise, these are the industry terms, and the TTP, the tactics, techniques, and procedure. That's where it comes in for you to analyze it, to say, hey, if, I know that this particular, IOC, this particular behavior, if it happens in my network, I know that something bad is happening. Is it happening, right? And this is where you determine whether an event is actually an event or an incident. So that's really the second component. And then the third one is your response. Once you detect something, how do you respond to it? So those are the three components within the security monitoring that we're going to explore, how cloud capabilities can help us. First is about the log management, and it's about the log collection. So all the cloud service provider, namely, again, right, like you have your Microsoft, you have your Amazon, you have your Google. You look up to the upper right-hand corner, they have services geared towards the log collection. Essentially, the long and short of the story is you pay them, they collect your logs, and they store it for you. That's how it goes. And some of you are going to say, hey, is it just the logs within the cloud itself? No, it's not. There's more. We'll talk more about it. So these services, basically, you pay them, and you pay them by utilization. So the more logs you store, and the longer you want to store it, the more you pay. And then these providers are also very smart. They collect all the logs related to their own subscription, meaning if you are using, for example, Azure, then Azure will collect all the logs within Azure very easily for you, and also let you collect logs from other places as well. So it's not just, okay, I use Microsoft, I'm in the Microsoft camp, I can only collect the Microsoft logs. That's not how it goes. It also supports the industry standard format, which is what we call the syslog. And it will collect all those formats and store it for you as well. On the right-hand side, hey, Microsoft came up with some really good marketing material about their capability. If you look at Azure, right? Azure is one of the more consolidated service here. So their offering is called a Monitor. And look at it, right? Like, hey, I am able to go and collect logs from the operating system within Azure, the resources, the subscription as well. And they also offer within the Monitor service, they have dashboard, they have view, they also link in with Power BI, so you can do a lot of deep analytics. that are more semi-automatic, right? And then they also have the respond capability and also to do the log analytics, which we're going to talk more about in a second. And also, hey, you have other deep analytics is able to actually export all those logs as well. So those are the capabilities that we're talking about here, right? Like it's a very vibrant ecosystem that helps you manage your logs. And to compare and contrast between those providers, here's a table here. Each of the CSP is a little bit different, right? So for example, AWS, if you are going to talk about the logs that are generated within the AWS platform itself, then that would be CloudTrail, is the service that AWS deem as the service to collect the logs. And then the analytics actually happens within CloudWatch. And then there are, within CloudWatch, there are a certain level of analytics as well. And one thing that I want to let you know is that, if you don't go and turn on some of these services, you're not getting the logging, right? So you may have the logging there, but if you're not saying that, hey, I need all these logs, then it's not turned on. And if you need to, if you have the needs to actually collect those logs, you need to go and turn it on. That's what it comes down to. And what does it really mean, right? And here is an example that is on screen here. For example, if we are in the AWS environment, we have an EC2 instance, which is their name for virtual machine. So how do you collect logs from a virtual machine? It doesn't matter whether it's Windows, it doesn't matter whether it's Linux, it doesn't matter which operating system. And by the way, this is not limited to just the cloud environment. You can have a on-premise data center virtual machine or just a Windows machine running. And you can install their CloudWatch agent, like, a piece of software that you can download and install. And here is the configuration file. If you configure it as such, right? Here is the configuration file. The logs will stream into AWS. Well, obviously you need to pay and you need to configure the server end, like the service end in the CloudWatch, you need to configure it. And then your servers, your computing resources are streaming logs over into AWS, and AWS is automatically storing all those logs for you, okay? So this is in contrast to, your traditional model. You would have to go and set up a syslog server, and then you would have to provision for storage, and hopefully all the logs are stored at the right place, and then you would have to figure out, do I have enough disk space for it? Now, using this CloudWatch service in AWS, it does it automatically for you, right? And what do the logs looks like? If I were to set up the EC2, the virtual machine to stream logs over to the service, what would that look like? This is what it looks like. I actually went and configured it, and this is some of the Linux logs, right? And within the Linux box, what happens is that within the Linux server, I added a user called an EC2 user. So this is what's going on within Linux. And this is within the console of AWS that I'm seeing all these logs. So, and AWS is kind of nice, that gives me the filtering capabilities over here. This is not all you can do, but at least it gives me a little bit of filtering capabilities so that I can filter out, look for the specific log entries that I'm curious about. So this is only the starting point of the log generation and the log collection. Okay. So far, so good. What about on the other side, right? So, people understand that I have network equipment, I have servers that are generating logs, and so far, I told you about how you can collect logs into AWS. What about the logs within AWS itself? Okay. So within the cloud platform, hey, your cloud service provider knows their platform really well. it also can capture all those logs. Earlier, I was talking about AWS has this thing called the Cloud Trail, which actually feed logs over the Cloud Watch within AWS. So here is an example of what that would look like. And I have to be honest, right? Like this is pretty, complicated. If you look at it, if you don't understand what's going on, that's fine, right? But the Cloud Trail generated this log entry to be captured within CloudWatch. What is going on here from a very high level? Somebody in this source IP address did something, right? And it seems to be using the AWS SDK. And the event that is happening, by the way, is happening on a Linux platform where this SDK is happening. And then what is actually happening is somebody assuming a role of this name. It looks like somebody is trying to get into this role to do some logging. That's what's going on. And hey, these logs are not meant to be easily readable. I mean, you can certainly understand what's going on, and which is why you need the analytics capability, right? Like, log collection is one thing. Somehow, somewhere, you need to be able to analyze them. But is that end all be all so far, right? We talk about the logs that are generated by your network equipment, your servers, and then the platform itself, the cloud platform itself, when somebody go and launch a virtual machine in your cloud environment, right? Those logs are generated. And is that it? No, there is more. The more is you can also log network traffic as well. In the olden days, in our traditional data center, I've certainly done it, right? Like, hey, I want to go and capture some traffic between this server and that server. You want to go and capture it? Good luck, right? So you probably need somebody to go to the switch at minimum to configure a port mirror, and then you may be able to go and secure some logs, right? That's the easy way out. And if your switch does not have that capability, you may be looking at actually a sniffer equipment to actually capture those logs. All in all, in the traditional data center, it may not be easy, right? Like it takes a lot of effort and setup work to be in the right place to capture those logs. But then all the CSPs, the AWS, the Azure, the Google, they all made this process very simple. So the capabilities within the cloud is that, hey, you only need to say that particular EC2 instance or the virtual machine or whatever virtual network instance, I want to capture the network traffic. And that's all you need to say, right? Then there are network traffic being captured. And we're talking about two different types of network traffic capture here, right? So on the left-hand side, you can actually capture the raw network traffic. So the bits and ones and zeros flying through the network, you can capture all that. Or there's an alternative that all these cloud service providers also support. It's called the flow. That's a metadata, meaning flow usually is only about the network address, source address, destination address, and the ports. And hey, when you don't need every single bits and details, you can actually capture the flows only. That's much less data to capture and might make your life a lot simpler. So those are the two options from a network traffic capture perspective. So we talk a lot about different logs that the cloud service provider are able to collect. So what do you actually need to collect, right? I have actually done all the legwork for you. I've actually gone to the 3 different providers and look at their best practice guides and consolidated the information there. They all recommend, all these different CSPs recommend the following data to be collected by the clients. So number 1, the computing resources, those are either your serverless or containers Or if you use the traditional virtual machine, hey, collect those logs. Because if you're running, for example, a virtual machine, a Linux server, everybody understands that your operating system log should be captured, right? That's not a option for most environments. And then they also recommend that within your cloud platform, hey, if you have any of the provisioning, starting of the resources and so on, go and capture those logs as well. Also, your storage, they recommend that your logs should be captured. However, one thing about those logs is that they do talk about the volumes. If each time somebody touch your data, view your data, you capture the logs, that volume may be very high. So they talk about that. Hey, maybe you want to moderate that. And then your application logs as well. I think all the cloud providers say, hey, you should capture all that. Whether it's serverless, whether it's your custom code, you should be collecting logs. And there are very specific guidance about serverless because, hey, that's a little bit different. When you want to capture those logs, they talk about refactoring to collect those logs, and then consolidate the logs between multiple accounts across different geographical locations into a centralized platform. And that centralized platform, generally people talk about the SIEM, and it can be in cloud as well. Now, that gets us into the next phase, right? Like earlier we talked about component number 1, which is to collect the logs. How about analyzing them? That's the components that we're going to focus on now. And that's the second component here. There are rule-based, log analytics where the CSPs allow you to write your own rules and let you analyze the logs for yourself. They also provide certain level of logic to help you with that process. Because, hey, if I ask you, hey, go and write some logic, you're going to be looking at me like, hey, what logic am I writing, right? So there are out-of-the-box rules that will look for malicious behavior. And these are integrated services. And we're not only talking about the AWS, Azure, there are third-party as well, like the Datadog, Defo. There are quite a few different players out there. Now, I'm borrowing something from Amazon. The guard duty is sort of the, very simplistic example of this. So, their promise is that, you enable that service, you pay me, right? You pay the AWS, and then you turn on logging, right? You turn on the CloudTrail, as we talked about earlier. You can capture your flow logs. The service itself have certain logic within it, and it automatically, like a Tesla self-driving car, it will automatically tell you when bad things happen, right? And then you can go and take actions, okay? That's a good promise. Now, what does that really mean? It means that AWS, in their own research, the Amazon folks go and did certain level of research, and they came up with all these different behaviors that they're able to detect. So I believe they have about 100 different rules, such that, when they see those behaviors in your environment, they know that you have certain risk. And they even give you the severity of those events so that it makes your life a lot simpler, right? Like you're not coming up with your own. At least you don't have to. Out of the box, Amazon gave you some logic to run with. And this is not just Amazon, like Azure and Google has the same thing as well. But they do it well for their own environment, right? They do it much better if you use AWS stuff for AWS, right? That's generally how it goes, right? Like they know their platform the best. So is it end all be all? Not really. The guard duty, for example, in AWS allows you to insert extra threat sources as well. For example, if you go and subscribe to different thread feeds, you can actually just insert it here within the guard duty service. And when things happen, it will alert you. And then you will have to write your own custom logic to say, this is how I want to be alerted. This is how I want to be notified. And this is how I want to be reacted to, right? But then is it, is there only 100 items that would happen that would be deemed bad? Probably not, right? What I'm trying to say is that the cloud service provider generally know their environment really well, and they will be able to write some logic to let you detect bad things that could happen, for example, AWS to the AWS environment. But then, do they know your application very well? Probably not, right? Which is where you, as a customer, probably need to write your own logic, right? We won't go in depth into it, but then there are continuous refinement of, you will have to engage your team to actually go. I highlight the fact that you would have to motivate your team, gamification. There's a lot of different practices out there that you can engage your own team to help you write those logic, right? The cloud service provider allows you to easily import those, into standard format, and you will be able to do deep analytics. And the cloud service provider gives you all these capabilities within, like, for example, the AWS Detective, Azure Sentinel, and Google has a Chronicle. They have a service called a Backstory. And those are really good and very capable, competent services that allow you to apply those rules into their platform. And their platform is looking at your rules at any given point of time, almost real time, so that they analyze your logs and tell you when bad things happen, right? And that's not just on a SIEM basis. Most people know what SIEM is. SIEM is your platform that actually detect and manage your security events, but they also get into the SOAR, right? Like security orchestration, automation, response capability as well. And these platforms, again, subscription-based, consolidate your logs from multiple sources, not just from your cloud environment, but you can actually port different log sources within your cloud, within your on-premise environment, consolidate into it, and then apply your smartest logic, whether it's coming from your cloud service provider, whether it's coming from in-house. It will be able to consolidate those services and, those intelligence sources, and you'll be able to analyze it from there, okay? So those platforms, by the way, usually cost a lot if you were to build it in-house. And these CSPs make your life a lot simpler, right? They make it widely available. You just need to turn it on and pay it monthly and pay it by the volume of logs that you feed through it. And you're able to get very, very, very good. And by the way, those capabilities, particularly like the Google Chronicle Backstory, those are, sort of the top most capabilities out there right now, right? So is that NO and BR that you can analyze it? Not really, right? You can also write logic to automatically not just analyze, but respond to the events as well. So responding means that you can enrich your data very quickly. The cloud platform makes it very simple. For example, in the olden days, when you're doing the on-prem, monitoring and so on, you would be like, okay, I want to get all these information and maybe go and secure an image of a server. Well, how do you do that, right? Maybe you tie into certain software components and so on. Well, particularly in the cloud environment, that's very easy. Nowadays, the cloud environment, hey, if you want a snapshot of your image, you can do that really quickly, right? It's a automatic response capabilities that you can build in with your platform. And obviously, you need to tie it with certain logic. But then once you have the logic, hey, to dream of something, okay, I want to, if such and such happens in my environment, I would like to, capture certain network logs And I know that that particular machine is dead, right? Like dead as in compromised. I would like to take a snapshot of it. All those things that you can dream of, you can easily do that, right? Over here, I'm using the AWS as an example. You can do in the AWS, if you have certain events that happens, you can write a serverless function and say, yep, hey, I want to, capture certain things. And you can even do active responses. What that means is that, hey, if such and such things happen, I am willing and able to, I call it cut off my arm, right? I'm able and willing to stop some of my services that are running, right? Trigger certain provisioning tools to remediate or even eliminate resources. You can do that. And obviously, hey, if you're going to go through that level of response, you better be careful, right? But hey, cloud is there to make things really, really responsive for you. So those are the capabilities that are available. So far we've been talking about the monitoring and response. Let's pivot over to some other capabilities like the crypto, right? Encryption. In the olden days, right, crypto tends to be something that everybody wants to do, and everybody thinks that it's easy until you actually go and do it. When you go and do it, then the question becomes, how do you encrypt and where do you store the key? Because who actually access to key, right? When you can access the key and the raw, encrypted data, you can decrypt it. Where do you store it, right? There are many different solutions out there, but they all are very costly, and it usually takes a lot of effort to set up and educate your developers, educate your infrastructure folks to use it appropriately. It's not just so much of a setup, but you also need to use it right, okay? And there are two types of encryption that we always talk about, right? One of them is in transit. The other one is at rest. What it means about in transit is that from point A to point B, right, from a network location from my laptop to the server, that would be in transit encryption. On the other side, at rest means that, hey, within the data center, when it is stored in a disk drive, for example, that's really where the at rest encryption is at play. So those are the two different types of cryptography in use. Now, in the cloud environment, the good thing about it is that in transit, from point A to point B, usually your cloud CSP will not allow you to go clear text. That's a really good thing, right? Actually Google tells you, right? Like they publish articles about, hey, depending on the connection that is made, hey, we encrypt everything, right? You can still forcefully go back and decrypt or turn off those encryption. Well, but if you go to that extent, then, sorry, you don't have any encryption. But most of the, point A to point B type of encryption are turned on, okay? So that's a good thing. On the other front, right, the encryption at rest, right? Like, that's where things gets a little difficult, particularly in the traditional, hey, on-premise, I have a data center, I need to buy some software to encrypt it. That becomes difficult, right? So the CSP made it very easy, okay? And, we're talking about like storage, encryption, and nowadays, right, where we are right now, this year, really 2020, a lot of the CSPs, if you go to the Google, the Microsoft, they can actually encrypt a running instance of a virtual machine as well. So, hey, that's a good thing, right? And the database, obviously, that's another target to encrypt the data as well. And one thing about it is that you can actually use this CSP encryption, and on top of it, you can encrypt the data again and again, right? So, it's not limited. They're not forcing you to do it. They're not forcing you to use it, but they offer the capability there for you to adopt it, right? And I can give you a hint, right? Like I teach a lot of developers on how to encrypt data. Is not exactly easy, right? the cloud service provider made it very easy for you because they standardize all these, API and so on, so that you can just call them and they will encrypt the data for you. That's what it is about. Now, when I say that, standardizing, there are really 3 different ways of which these CSPs are encrypting your data, right? And you might ask me, hey, is it just for Azure? Is it just for GCP? No, they're all the same, right? So the good thing about it is that they made it very standardized across the platform. There are obviously the name of the function that you're going to call in Google and in AWS a little bit different, but the model of the encryption and how they handle the encryption key is really similar. And why do I spend so much time talking about the key? Because that's one of the biggest challenge within encryption, okay? And there are really 3 different ways of managing the encryption key. You as a customer can say, number 1, let the CSP handle it. I don't even want to handle the key, right? Like, hey, just handle it for me. Number 2 is, yep, you get involved in it. You're like, okay, I will turn on this key management service and then I'll establish the key. But that's the extent that I want, right? Like, I know that there is a key there and I can revoke it if I want to, but I don't really want to manage it too actively, right? So I use another cloud service to actually manage the key. That's the second methodology. And again, like these methodologies is across all the cloud service providers. And number 3 is really the hands-on one, right? Like if you are very paranoia or if you have very sensitive cloud security requirements, you're like, hey, CSP, yeah, I really need to manage, all that stuff, right? I'm not trusting you to manage it. You can provide your own key, right? You can generate and provide your own key to the CSP. You can do that as well. So they give you all sorts of different capabilities to manage your own key, okay? And when I say it's easy, what do I mean? I'll show you, right? So what I am showing here is the S3, right? Like it's a storage component that I just established within, this is AWS CloudFormation, like basically the configuration template for a storage area. All I need to say is, hey, S3, I want encryption. And where is the encryption coming in? Oh, sorry, where is the encryption key coming from? It's coming from the key management system. That's all I need to say. And then, guess what? AWS go and manage it and encrypt it. And then the key is coming from this KMS, okay? That sounds really simple, right? And literally, it is that simple. That's why, people like cloud, right? Like the management of the key is pretty seamless. And the encryption itself, wow, right? Like all that data is automatically encrypted while it is in the cloud environment. And there's a little bit more that I also want to cover is about, the key management. The cloud service provider gives you a lot of different options about the key management. Earlier, I talked about the KMS, right? The S3 bucket, the storage area will automatically use the key within the KMS. And where is that key coming from? It's basically the customer master key. Like, hey, there is the actual master key. That is the key to the kingdom, right? Once I generate that key to the kingdom, then it will manage all the rest of the key, automatically. So that makes things very seamless, okay? There are many different models that, you can go after, and we won't go through the details here. But, what about that key to the kingdom? How do I protect it? Guess what? There's also additional services that these cloud service provider also provide you, right? It's called the HSM, is the hardware level, security modules. And those used to be, hey, I remember, I used to work for a major bank, a large global bank. And I remember supporting those, HSMs that cost multiple millions. And then each year you spend millions of dollars just managing them, right? Like nowadays, you can actually is very cost effective, right? Like for example, GCP charges $1 per month for a HSM managed AES key. Wow, that's really cheap, right? So these particular solution is hardware based, and generally all the CSP basically give you a virtual instance to put into your virtual network. Some of them manages it for you, some of them don't. But essentially, they give you a guarantee to be FIPS 140-2 level 3 compliant. What does that mean, right? Those are the military and financial standard to say, yep, hey, if you meet this standard, you're really good, right? And they will manage the key. And essentially, the long and short of that story is that the key never leaves that hardware module. And you only let that hardware module manage your key, and that's deemed to be very secure, right? So what can you do with all these cloud managed HSM? You can do for example, everybody knows that there's SSL, TLS encryption, but all that encryption is based on a key. Where's that key? You can store it within the HSM, okay? And that key never leaves once something is in the HSM, it never leaves the HSM again. Once you store the key, you're like, hey, here is a piece of data that you need to encrypt for me. That's what happens, right? So you keep your encryption key very safe. And then people use like different PKI solutions. And once you do any crypto, you can go back to this HSM. So basically what we just walked through is, the crypto capability is, one line of configuration. You say, hey, I want to turn on this particular feature and encrypt it for me and make things really seamless. And, it's almost too easy. Sometimes when I am coming from my background, having to write lines and lines of code, to do encryption and installing multiple different solutions, that's almost too easy. Now, also, other than the crypto side, I also want to talk a little bit about the DDoS and also the DNS capabilities. What those are is, hey, in your traditional data center, right? Like these are very hard problem to solve, very hard service to provide. DDoS, right? Distributed denial of service. I don't think I need to talk much about it. Basically, is a lot of traffic all of a sudden coming to your pipe, coming to your data center, and overwhelm your services very quickly. And in order to defend against those, you really want the cloud service provider. Why? Because they have gigs and gigs and gigs of traffic, and they know how to filter them, okay? So, most of the data center that I've been in are like, maybe gigs or tens of gigs, in pipeline sizes. But hey, the AWS, the Google data center, you bet they have a lot more data. They have a lot more data rate, right? They can take on all those attackers from multiple different countries, location. They have been known to defend very successfully. And guess what? If you use some of the load balancers, which you should, right? Any of your web applications and so on, you should be using a load balancers because, hey, how else would you actually guarantee your availability, right? So when you use those load balancers, you can turn a feature on, and they will automatically defend against DDoS attacks for you. I am obviously trivializing, simplifying here, but that's the capability that the cloud has, right? And that's a very effective way of preventing people from overwhelming your data center, just by traffic, right? And that's a DDoS scenario. And then the DNS as well. DNS is a very crucial service for your website, for your entire web presence, right? So when you say .sans.org or whatever website you're at, there's actually no such thing on the internet, right? Like you're at the end of the day going to an IP address. So the DNS basically translate the name into an IP for you. And if without that service, you are going down, right? So how do you guarantee that service is up? Well, you use some of these, DNS hosting services that the cloud service provider provides. And why is that important? Because if you host it in your data center, those things will get attacked, right? There is the DNS amplification attack. There are multiple different factors. DNS is notorious for being very difficult to manage. And only if you have multiple different, at least you have to have a security expert managing it on 24/7 basis. And then you have multiple infrastructure people watching it, unless you're doing that, don't host your own, right? Let the experts manage it for you. And for the prices that you actually pay for these, cloud service provider to manage it, it is, definitely worthwhile from a security and from an availability standpoint. I can tell you right now that, I do a lot of comparison between all these different services. While I can tell you that AWS, Azure, and GCP is not the topmost provider by latency and by availability, they are definitely within the top 10. So, I basically watch it, on a very, very regular basis. They are very good, right? And there are other people in this DNS hosting and also DDoS, anti-DDoS mitigation type of services like the Cloudflare, the Akamai. They're also very good, right? So my point here, on all these different capabilities is that once you get into the cloud game, these capabilities come very natural as a natural progression for you, and it's very easy for you to turn on and get you there very quickly, right? They think of them as bonus when you move into your cloud environment. I think that's all I have for today. And again, some of these material is aligned with the MGT 520 course that I wrote recently. And, hint, hint, I think that course is debuting in about a month time in February. And I think we're running it again in April as well. Hope to see some of you guys there if you like this material. And I will take questions now. You can use the QA functions, the Q&A functions. I'm happy to take them at this point. There's one question from John asking me, is there a way to log for IMDS version 1 usage? Let me reiterate what the question really is about. John, if I'm not answering the question appropriately, feel free to let me know. Basically, the IMDS is a way for for the resources within the AWS environment to query for the metadata, right? So particularly what's of interest, and some of you may have seen the Capital One hack, allegedly, there was a lot of, association with this IMDS version 1 metadata. And so there was a lot of focal point on whether you can actually lock it. The Cloud Trail actually locked any of those, hey, if somebody were to steal your credential using the IMDS, there is actually lock entry to the point that, it will actually tell you the IP address of, where that IMDS is actually rendered as well. So yes, the short answer is yes. Most of those very sensitive operations are actually locked. And this goes, beyond just the AWS, right? If you go on the GCP, it is the same thing. All those API level call are actually captured. And why would I say API? In case, some of you coming from the management area, hey, when we say the cloud, all of the cloud platform are just a bunch of APIs, right? So when you actually go and launch a virtual machine, in the background, you may be going to a web console to actually do that. But in the background, it's actually an API call that your web browser is making to call the web services to invoke a virtual machine. So there's a lot of API calls that are happening. Hope I answered that one. And then David is asking me a question. Let me flip that over 1 second. Do you think CloudWatch Logs is mature enough to replace something like Splunk? Ah, okay. Hey, you're asking me for my opinion. I will give you my opinion. I have done a lot of comparative, between the 3 different platforms and also Splunk. I'm a very active Splunk user, and a couple of the other SIEM solutions as well. Like, hey, I'm good friends with with the people from IBM and the Micro Focus and so on as well. So I've had a lot of different experience. I would say, my honest opinion is this: the GCP, sorry, not the GCP, the Google Chronicle, the backstory, amazing, right? They bought that one and it's very good. Is CloudWatch almost the same magnitude? Unfortunately, not quite. I have heard of a lot of storyline, from Amazon saying that, hey, we're going to improve that a lot more. I have heard about it. I haven't seen the actions yet. So would I personally use CloudWatch to replace, something like a Chronicle backstory, Curator, or some of those? Not today. Splunk, maybe? No, not today. But hey, it's promising. Would I, David, to turn it around a little bit, would I use CloudTrail? Absolutely, right? Like, you need CloudTrail to generate all that logs, and feed it into cloud. These days, I do recommend that people use CloudWatch as a event generation, right? So what that means is I will use CloudWatch to feed the logs elsewhere. And then, because if you use CloudWatch to invoke the logs, invoke the notification, is much quicker. So I would start there, but that's not the end story. Usually I recommend people to move the logs away from AWS. That may not be what you're asking me, but hey, that's a story I'm sticking to it. Yeah, oh, okay, cool, thanks. Yep, so David just said that, yep, that's what he's looking for. If you have any other questions, I'm happy to answer them. Just let me know here. Yeah, so the logging side is definitely very interesting. I think a lot of people are looking to replace even Splunk. I don't think that AWS is matching up to it. I do think that Google is very close to it, right? And then don't forget, Splunk, is very good, not just because of the analytics capability, is also the other user plug-in that other users and vendors have written. I don't think that any of these 3 different AWS, the Azure, and the GCP is quite there just yet, right? Hey, maybe one day it will be, but not today. But it's very promising, right? So waiting for more questions, and if not, nothing is coming up. So we'll probably end the session here. I want to thank everyone for attending. I hope you find this information useful, and hope to see some of you guys, at a next conference or at the next SANS class. Thank you. Thanks a lot. Oh, one question here. Any idea if a second beta will be scheduled? The current one is scheduled for February, and then there will be one in April. I think it's April 2nd week. Hey, keep looking at the schedule online. I think they will publish that class very shortly. Yes, and the February one is beta 1. So we're going to fix up some stuff and run another one in April. Yep, thanks for asking that, Dustin. All right, we're going to end the session here. Thank you.